Hi, everybody. Kubernetes SIG architecture, May 18th. Looks like, let me share the agenda. So the only things I see on the agenda today looks like they're from Rian. So why don't you just take it from here, Rian?
Thanks, John. Yes, we are in the swing of things at the start of the release for conformance testing. The 12 endpoints for API resources that lost their test in the previous release. We have created a new test, which works quite nice. It's done its time on the test grid for the E2E test. The promotion is ready. We have reviews and a bit of discussion. I think it's good for if somebody just to have a look through that. I think it is good for a LGTM and improve. If somebody can do that for us, I'll really appreciate. Then on to the next point is all the endpoints that is open that requires testing at this stage is on the pending eligible endpoints YAML file where we store them to keep the 100% test coverage that we've achieved. So every time we have endpoints, the promotion merging, we need to actually take them off the list so they can properly show up in API step. So the second PR is just a administrative exercise to move those endpoints off the list and get them to show up.
Okay. Okay, great. Well, I'll try to take a look at those then today or tomorrow.
All right, and then the next one, we've been to SIG storage this morning. There is 3 endpoints for CSI driver that has not been tested. So what we've done is, as part of the cleaning up of test and making as small as possible a test footprint, we took the existing test for 4 endpoints and combined it into a lifecycle test, updated it a little to conform to the latest test requirements, and adding the 3 endpoints. So basically now we have a 7-point lifecycle test that they had a look at this morning. There's a small nit. I'm sure it will merge as soon as we sorted the nit. And yeah, and as soon as that test is merged, the promotion is merged later on, we will start monitoring for properly somewhere just before the end of the release. If everything runs fine, there's no flake, we're going to remove the old test for the 4 endpoints to reduce the, so as the new test covers everything, to reduce the test footprint.
Okay, sounds good.
Then the last one, there is a test for empirical containers. 2 endpoints being tested there. It's checked, it's merged on the test grid, everything's green, just for information, no action needed there.
Okay, so that's just
everything.
And once we see that's soaked, we'll promote. Okay, awesome. So I see we have a new person here, Derek. Hi, welcome. So just a little bit about SIG architecture. So SIG architecture sort of looks at, we have a few different sub-projects looking at conformance, and conformance testing is one of them. That's what we were just talking about. Another one is code organization, which looks at sort of the dependency management, all the dependencies that we're building into, that are part of Kubernetes, and trying to make sure that we don't have dependencies that we shouldn't have, and that sort of thing, and reduce the dependencies. Another group is our API review group. So all of the whenever somebody's building a new API in Kubernetes, we wanted to follow certain conventions and certain design principles. And so there's a sub-project within SIG architecture that kind of manages that process and makes sure that those APIs get reviewed and approved. And then we have 2 more sub-projects, a lot of sub-projects. Another one is production readiness reviews. So that's an area where we look at enhancement proposals and make sure that those enhancement proposals are thinking about different situations that could result in production failures, and making sure that we can troubleshoot those, prevent those, and that sort of thing. And the last one, I think, if I remember them all, is the enhancement sub-project that really looks at process around how enhancements are proposed and approved and developed within within the Kubernetes project. So that's kind of the sub projects, and then sort of we also are sort of just a general place where we ask questions that have broad effect across the project, particularly the technical not effects, as opposed to community type things, which would be in a different SIG. So that's kind of a super short description of what SIG architecture is about. Any questions or any of those particular areas sound interesting to you?
Oh yeah, I was wondering, what would be a good place to start? Or how is the onboarding process normally?
So for this SIG or for Kubernetes in general, I guess would be the question.
I'd say for SIG, because I see for Kubernetes in general, it seems to be a bunch of, separate, I guess, meetings.
Yeah, so there's have you looked at any of the community documents around, like, I think we've got some documents describing like some community onboarding documents for the broader Kubernetes community. So I'm just trying to get a feel for whether you're already familiar with all that and you've chosen SIG architecture because it's an area of interest to you, or you're just trying to figure out what the different parts of the project are. I don't know where you are in your stage of.
No, yes, I've checked that out, and I'm interested in SIG architecture. I even looked at a few YouTube videos and like the playlist.
Oh, okay, cool. I would say that if you're familiar with, so it all depends on your interests. Production readiness can really use, Tim's got something to say. I'll let Tim chime in before I talk.
Oh, I was going to follow you up, but okay.
No, okay.
The truth is, I think SIG architecture ends up being SIG everything else sometimes. When a problem or a topic doesn't have a natural home in one of the technical SIGs like network or storage or node or API machinery or CLI, we say, punt it to API machinery. This is where we do conventions and standards. This is where we do API coverage. This is where we do code organizational stuff, directional, should we move things around the file system or the repos or things like that. So in some ways it's a catch-all, which makes it attractive in that sometimes there's no learning curve, but other times the learning curve is you have to understand every other SIG in order to understand what this SIG is catching at the end of it. We're the default case in that switch statement. So anyway, I just wanted to say, depending on what the things you're interested in doing or achieving, or if you have an itch that you're trying to scratch, we would give you different guidance.
Okay.
Yeah, and just to maybe do another way to think about it is in terms of what your existing skills are. So like API review, you need deep understanding of Kubernetes specifics. Like that's like what the API review team does. So, that's usually, like Tim saying, super high learning curve on that. But if you go into the code organization, you need to understand Go. You need to understand how to build Go things. You need to understand Go dependency management. You don't necessarily need to know all the functionality of Kubernetes. Or if you go into production readiness, you need to understand, you probably want to have a good understanding from a user perspective of Kubernetes and a good understanding of managing fleets of distributed systems, right? So it's like gosh, word finding issues here. An SRE would be a great person who could provide a lot of value in PRR, but might struggle in API review, right? But somebody who builds APIs for a living would do great in API review, but might struggle in PR. So it kind of all depends on background and things like that. Enhancements is more process oriented. It's like more like program management and that kind of thing. Missing one. Conformance is actually kind of a neat place to start. We'd have to ask Rian what the sort of capacity is. If you understand Go, you know how to build tests in Go, and you want to learn a lot about Kubernetes, you end up, the conformance program, what it is it's saying, hey, these are the APIs and the tests for those APIs. that have to pass in order for a distribution to call itself Kubernetes. And so you have to learn about, like, what does this API do? What does that API do from a user perspective? And then you have to build tests that make sure it does what it says it's doing. So like, that's a different angle on it. So like Tim said, it's kind of a catch-all, and it varies with what you're interested in doing and your background.
Okay, yeah, conformance sounds good. So about me, like a newly laid off employee, I was a senior full stack developer at NASDAQ. We did a lot with replatforming our old NFN system to AWS Cloud. So I got to touch a little bit of Kubernetes, but not that much.
Okay. Yeah, then that might be a good place to start, because you start to get an idea of the whole picture and how, because what you're working on are end-to-end tests actually. So right, so you're seeing like how the different APIs work. So I guess I would ask, okay, well, Ray, I mean, okay, let's take that in a minute. But so Rianne, Rianne's been running that program primarily on the conformance side. I'm technically one of the sub-project leads for that, but like he's really been doing the real work. So what do you think, Rianne? Is there a way we can plug Derek into the work you guys are doing?
Absolutely. If Derek, you can just ping me in Slack, and then we can set up a meeting, and I can quickly take you through the work that we do, show you where's the list of endpoints that we're still working on, the tooling that we use, API Snoop, how you can track things. So give me a ping on Slack, and then let's catch up on that.
Excellent, good.
Awesome. And just so you know, Rihanna's in New Zealand, so his time zones are pretty different from the US time zones. So but I'm sure you'll find that out when you reach out to him on Slack. It looks like we have another comment, Ray. So if you just heard our pitch for SIG architecture, right, we're kind of a catch-all. There's different areas. So you heard that's an area to get involved. As far as AI, I don't think, Tim, do we have any SIGs looking at application of AI to Kubernetes?
SIG Node is always looking at things like accelerator integrations and the APIs there. And I would say SIG apps is looking at workload configurations. And if there are opportunities to do better for specific sorts of workloads, that would be in SIG apps.
Right, so that's around the idea of using Kubernetes to host AI workloads. So if that's, when you say good with AI, if that's what you mean, like you're super familiar with building platforms or running models and the use cases around running those models and all that stuff, then yeah, probably SIG Node and SIG apps are good. Like SIG Node is really about like, hey, this node needs GPUs, and so like it gets into the, or this workload needs GPUs, so how do we support those within the node? There's a bunch of device manager things going on there and APIs around how to manage different kinds of special purpose, compute cards and things like that. That's super cool stuff going on in Node. And then SIG apps would be about how do we run those workloads kind of the higher level service. Which nodes do we put them on? Do we need to run these concurrently versus, how can we parallelize them in a batch versus do we have a separate, is batch now a separate SIG, or is it still part of apps and just a working group?
That's a great question. I know there was talk of making a separate SIG, but I lost track of it.
Okay, there might also be a SIG batch. We're not sure. If there is, that also might be of interest to you. So I hope that answers your question. Anything else?
Sorry, I'll add one other thing too. Like for newcomers, there is no end of improvements needed in the project, code-wise, factoring-wise, test-wise, docs-wise. SIGArch isn't the most obvious place to start on those things, but it is a breadth-first introduction, maybe. I would say for people who are new and looking for ways they can contribute, pick an area just that seems interesting. It just has something that like you go, oh, that's interesting. I know a lot about that, or I don't know anything about that. And if you can jump in and start fixing up code, fixing up tests, looking at comments, do they make sense? If you know Go, there are Go patterns that maybe we don't use or we should use, or things that stand out. There's no end of those things. And then in my experience, that's how people find either, you know what, Node really isn't interesting to me, I'll go try something else. Or, wow, I love this, I got some ideas, and you grow from there.
All right, thank you. Any other questions? Otherwise, we will finish early and get some time back.
So what's the time expectation?
Well, as much as you are able and willing to give, obviously, if you want, so we have something we call a contributor ladder, right? So the idea is that some people come by and they are using Kubernetes in their job and they find a bug and it annoys them and they make a commit to fix it and they disappear. That's a drive-by, and that's totally welcome and just fine. Then you have people who are like, no, I want to really get involved and I want to be part of the community. So then you start coming to the meetings like you're doing now. You start looking at the issues. Some of the meetings, a lot of the SIG meetings will have a triage session where they go through issues and they say, hey, can somebody take a look at this, dig into that, fix this. You maybe pick up some of those. Some of the repos will have a good first issue, and the tag labels, some things will be labeled good first issue. The idea there is these are things maintainers have decided, this is approachable enough for somebody who doesn't know everything to come in and start to learn and start to build their knowledge. So the more time you give and the more contributions you make, then you can go from being, sort of a regular contributor, becoming what we call an org member. So in GitHub, there's an organization which grants you some authority, like you can do an LGTM if you're in the org, which merges things, assuming it's been approved by the owners. So like it gives you, it allows you to be assigned issues. So it gives you some additional privileges in the strict sense of GitHub privileges. But you need to reach a certain number of, there's some discussion of it in the community website. I can't recall offhand, but there's certain number of contributions, and so show some body of work and say, hey, I've done this many PRs and here they are. And, or I've commented on issues and I've given feedback, I've done code reviews, because that's super valuable too, not just producing PRs, but doing code reviews is super valuable. So once you've reached a certain level, and I'm not sure what that level is these days, you can apply to become an org member. Eventually, if you're in a particular SIG and you're doing a lot and contributing a lot, you become really familiar with the code in that particular code base, you can become a reviewer. When you're a reviewer, it means that you'll get automatically assigned the job of reviewing PRs that come in. And then the next step up is an approver. Like you own that piece of code, you understand it deeply, and you can approve other people's PRs on it. So this is kind of the ladder. And where you end up on that ladder is dependent on your interest and level of commitment and level of participation. Yeah, Tim.
We are mostly a volunteer army. There are, at the center of it, there are people who are paid to work on this, but the vast majority of people who contribute to Kubernetes do so on their free time. So there is no assumption of time commitment. You contribute as much or as little as you have time for. I totally lost what I was going to say other than that. Shoot, I had another thought and I completely lost track of it. You don't have to be a capital R reviewer to be reviewing.
Yes, good point.
Right? Like code review is a many hands make light work sort of thing, or many eyeballs make for shallow bugs. The more people look at and review code, the easier it is, and the better the code base will be. Right? So anybody is welcome, to the recording, and everybody who might watch this in the future, everybody is welcome to come and take a look at any pull request they want to look at. If it's simply a matter of this code could be better, your opinion is welcome. There are often architectural considerations and other things, that's fine. But anybody who knows Go can go look at a Go PR and say, hey, this might be an easier way to do this, or did you think about renaming this thing? Or, those sorts of code level reviews, absolutely welcome. That's the little r reviewer role. Anybody can do it.
Okay, nice. And as far as etiquette goes, would you need to post in the Slack or something if you don't have much time, this week or something?
So if you've committed to something, but nobody's tracking you, right? So like you don't need to do that. But if you're like, hey, I'm gonna get this issue done by next meeting, and then for some reason you can't, yeah, the etiquette would be you'd say, hey, you know what, I got family emergency. I'm not gonna be able to work on this week. Maybe we can hand it off to somebody else. But like, there's no, like Tim said, we're all a bunch of volunteers. There's a planning cycle we go through, and every SIG is going to be different because it's going to depend on who the leader of the SIG is. But the planning cycle itself is for the whole release. And so, there'll be a tech lead and a SIG chair that is looking at the different features that the SIG agrees, hey, we want to get these features into this next release. We're targeting this release. And so at that point, you might volunteer and say, yeah, I can help with that feature. I'll take this piece of it. And so you're establishing then an agreement or a commitment to the team that you're going to deliver that. And so, you're expected to live up to that commitment, or at the very least communicate about challenges you have along that path. When we're volunteers, you can't always, maybe your day job. We have people who are in, very deeply involved leadership positions who are like, I can't do anything this week because we have this, there's this, meltdown in production and I need to deal with it, right? And then other people will pick it up, right? Like, we're all helping each other out, and so there's no top-down expectations, I guess.
Okay, nice. And are there any I guess regularly scheduled office hours or like pair programming sessions just to bring people up to speed?
There are some mentor programs that the SIG contributor experience has run. I don't know if those are actively going now, but usually people are really friendly and really welcoming. And so like, if you go to a SIG meeting, you reach out like Rian, right? You see how friendly he's like, hey, just ping me on Slack. Let's get together. Let's do it, right? That's the spirit we have in this community, right? And he's reflecting that, right? Like, I think you'll find a similar spirit in all of the SIGs. So if you're like interested in helping out in a certain area, people will help you do it. I mean, everybody's busy, all of that, but like generally it's a super welcoming community.
Yeah, I would add to that. The best way to get started there is really to pick a SIG of interest, a technical SIG of interest. SIGArch is sort of pseudo-technical. Because the project is so big and so broad, all the technical expertise, all the domain knowledge is generally centered in individual SIGs. So if you decide you want to do something network related, you pop into the SIG network Slack and you say, hey, I've got this idea, or I'd like to take this bug, but I could use a leg up. Somebody often will be there to either give you advice in real time or to schedule something in the future.
Victor?
Yeah, well, first of all, yeah, I've been in the community for several months, and I definitely agree that the friendliness part, I wish I worked in a place like this before. Very friendly. Then some question regarding the architecture. I'm not a developer, I'm a database guy. And then, but I find, so is it true that to understand inside really the fundamental internals of how Kubernetes works, it's better to understand the API machinery? Is that true?
I mean, I think I see Tim smiling. So okay, opinions, right? I have opinions, right? So it depends on what you mean by the internals of how it works. Like the declarative management of containers and networks, networking between those containers and load balance and all this stuff, right? Like you want to understand API machinery so that you understand how that whole management layer works. But, if that doesn't tell you anything about how the networking works. That doesn't tell you anything about, or maybe very little about how the actual, kubelet works. So like you can think of it in terms of the components, right? So node, kubelet's the main thing in node. In network we have a few things like kube proxy and CNI and a few other. There's a number of pieces in there, right? And then API machinery has the infrastructure for building those APIs and the controllers on top of those APIs, but the actual controllers themselves are in the different SIGs, right? So like API machinery is another horizontal SIG. Like you can take the technology from API machinery and use it for anything. We happen to use it for container orchestration right now, primarily in Kubernetes. And so then the SIGs are those vertical pieces on top of that. So kubelet manages the containers, a bunch of different controllers manage the networking. So I think it's a hard question to say how Kubernetes works because there's so many different aspects to what Kubernetes.
Yeah, maybe put in more context will be easy to understand. So because it's more for me, I'm a first of all, I'm a master in physics, so I like to know how things work. And then second, I'm a database consultant, so I don't need to develop to make a living. so my really is to understand how Kubernetes is built from ground up and components. So for example, if I need to understand how it relates to in the future, database security, whatever it is, just understand basically the foundations of how it works. It looks like API machinery is the pieces.
You're going to get into a lot more detail in API machinery maybe than you need, but like architecturally, so this SIG is in some ways good for that, right? Like architecturally, I tend to think of it as we have the API server, which contains the ability, effectively a database with an app server on top of it, and a kind of declarative API structure. So the structure of the APIs themselves are declarative and built in such a way that we separate the specification of the what we want, the declaration of our intent, from the actuation, and those controllers are actuation. And so what happens is you get, that's sort of like the very high level architecture. So when you say how Kubernetes works and what it does, well, it always works that way. It's always you create an API resource which represents what you want, your intent, and then some controller actuates it. Now, some controller actuates it for containers means, kubelet takes it on a node and creates a running container. Actuates it for a network is going to be a different controller. Actuates it for a load balance service is going to be a different controller. It ties back to the network and configures the node. So like it's like super 10,000 or 30,000 foot level. It's you take specifications and you store them in a database, which validates them and makes sure they're all consistent. And you take actuators or controllers that take that intent, actuate them in the real world, whatever that means, and write the status back to the API so that you can see what happened. Like that's basically the whole thing. Tim, I don't know if you agree with me, but that's how I see it.
Look, Kubernetes as a system is sort of a fractal. Like from a high level, John just gave you how the system works, and then you pick a piece and you zoom in on it, right? And so you said you're interested in databases and you asked about API machinery. I love API machinery. I think it's the most interesting subsystem in the project, but it's not the easiest thing to approach. But say you want to zoom in on that and you're interested in API serving infrastructure. Okay, cool, zoom in on that. Well, the API server is itself a distributed system that has multiple replicas that interact with each other. It has admission control. It has logic for processing HTTP requests and verbs. It has logic for doing optimistic concurrency and patch merging across those things. It has logic for, random generation and common infrastructure. And at the bottom of that is a data store, and you do all the work and you write some stuff into the data store. And if you say, well, I like the data store, I'll zoom in on that. And well, it's actually built on etcd. Etcd is itself a distributed system which uses RAF to establish quorum between multiple replicas and stores data. And you can zoom in on that and say, okay, well, what's going on inside etcd? Well, there's a cache and there's a on disk and there's memory and you get what I'm saying, right? Like, so which thread you pull on, it depends entirely on what's interesting to you and how far you want to zoom in.
Yeah, it's something. I know this is where I find it. So there's so many things to learn, but it sounds like the like if I say there's anything has a foundation, right? This is the basic foundation where it all start from. Is API machinery that particular one, or there another one that's
if Kubernetes has north of 10,000 people working on it on any given release. So of those 10,000 people, how many people have to really understand API machinery? Probably about 25 people, not 25,000, 25 people. Because the API machinery mostly just works and it does its thing. And the people who are doing the customer facing work, they're all building on top of it. And that abstraction layer is effectively sealed. You don't need to crack it open. If it's interesting to you, there's plenty of work to be done there. It's not really done. But it's done enough to achieve the goals that most customers have or most people want to achieve. Want to deploy a container? We've got that for you, but that's built on top of the API machinery. You don't need to peek inside. It's like writing a program on Linux. Do you need to look at the kernel? You don't have to. You can if it's interesting, but most people don't need to.
Okay, yeah. No, I'm actually not a developer. I'm just interested in the really high level how it works at this point. So what I also find interesting is I actually look, for example, like OpenStack, right? My understanding, OpenStack, they have each individual component, whether it's storage, authentication, each has its own code API machinery component, whereas Kubernetes is just have a unified API machinery. So it's kind of sounds like Kubernetes is really done very well in the beginning, have a well thought of foundation for everything else.
I mean, that was an architectural decision that was made really early on to have a consistent API across all of the resources that we host. It has enabled a whole ecosystem of really neat tooling that you can use that doesn't care what API or which subsystem you're talking to. Networking and storage and Node are all the same framework for API. It has its own downsides, like it makes some things sort of awkward, like non-declarative things. Occasionally you really do need to do something imperative and you have to sort of bend over backwards to make it fit into that model, right? Like requesting a certificate is a little weird, right? But it's okay, we make it work.
Okay, yeah, thanks.
Awesome.
One other question.
Sure.
So, what would you say the I guess the project format or methodology is for development in the SIG group? So, is it a waterfall? For features, do you just check issues and
So there's a little bit of a okay. So for new to feature development, it's it's a little bit waterfall-y in that we have what we call an enhancements proposal, where part of because it's open source, there's a lot of consensus building, right? And so in that sense, you have to do a lot of upfront work, but it's also iterative. So one of the things I like to say is my dad used to say this because he would go to the little town meetings in our little tiny town, and he'd and nobody would show up but him and one other person. It's like, okay, yeah, we're gonna plant those trees there because nobody else is here to say no, right? Like the people who make the decisions are the ones who show up and participate in an open source project. So in that sense, there's consensus building. We have some processes to make sure people don't go AWOL, but for the most part, if you want to do something, you can do it. You can get something to alpha, without too much resistance if it's not too crazy. But the what am I trying to say? So the process though is like, if you're going to do something big, like I want to add some major new feature or make a significant change to an existing feature, then you're gonna create what we call an enhancement proposal. And what that does is it facilitates discussion and make sure that the right people have the eyes on it. If that's not something you'd normally do though in your first 6 months on the project, right? Normally you'd be more going to, Tim just said it in the chat. You'd go to the SIG meeting, talk to the people in the SIG, talk to the TL of the SIG, talk to other members of the SIG, say, hey, what are some good bugs that would be good to start with, or go look in GitHub, and if they've tagged them with good first issue, like that's going to really help you come up to speed and understand the concepts. And for those, it's just, we have a train every 4 months we're releasing. And if you get your code in before the code freeze of that train, then your code will go out with it. So it's not waterfally in that sense. But if you want to develop a new feature, there's definitely more of a consensus building process.
Okay, so what will I look to for, something like a spec or, requirement traceability or anything like that?
So we have there's an enhancements repository that contains all of those KEPs, and it documents those enhancement proposals document, hey, here's the motivation for this feature, here's some use cases, and here's our proposed design, as well as among other things, test plan, things like that.
Okay, and just for issue tracking, you just use, GitHub issues, like
Yeah.
if you were using Jira or something like that.
No, it's all GitHub. It's all GitHub.
Yeah, and look, I don't want to. I agree with everything John said. I don't want to discourage people from trying to take on features. The anti-pattern here is that people show up and don't understand why decisions have been made the way they've been made, and then they come in swinging for the fences, and they waste a lot of time on something that can't be done or was already considered and rejected, or needs guidance from people who have deeper roots in the project. And I hate seeing people waste time. So I always encourage people to, start small, make sure you understand what's going on, what the lay of the land is, what's already in flight, what can you participate in on that. If the thing that you're interested in doing is a feature and it's of relative size that you can, manage it, and it fits within the bounds of what a SIG is doing, by all means, you can do features as your first interaction. But I would strongly encourage people not to waste a lot of time designing or coding a major change until you're confident that it fits with what's going on. And that's not just true for new people. That's true for me. I've been around in the project for 10 years, and still I will come up with an idea and I'll write it down, and then people will shoot holes in it because I missed some aspect of it, because the project is millions of lines of code, and there are things that nobody knows everything about the project, and so there's things that even I will miss. So
Tim knows almost everything though.
Oh no, whenever I need somebody to shoot holes, I know who to go to, but
yeah,
it's not one person, it's a list of people, right? And so I always recommend, like, start small and iterate quickly so you don't waste a lot of energy on dead ends. But that doesn't mean you can't write features. As a project, we have a core ethos, though. We say all the time, chop wood, carry water, right? The people who show up, that build the community, who do the service work, are the people who tend to have the most success in the long term, because they understand the project, they understand the community, and they've sort of built some cred of doing not just the fun feature work, but actually the hard work that keeps the project alive. In fact, we give out awards, the Chop Wood, Carry Water Awards.
Any other questions? This has been a great discussion on this.
Oh yeah, one other thing. I may have missed it going through the contribution doc, but is there I guess like an architecture diagram? Like Stuff like that, like a glossary or anything like that. Get familiar with any like specific technical jargon or anything like that.
There used to be an architecture diagram. I don't know that it's been updated, and I mean, not that it really needs much updating, but let me see. I mean, there's a lot of stuff around the like if you go to the Kubernetes.io, you'll see, you know, the concepts section of the documentation and things like that. Those are outward facing towards the world. That said, we've also have the developer contributor. Let me find it here.
I just linked the developer guide under.
Thank you. Okay. Yeah, we also have the developer guide. It's going to talk about a lot of those things as well from a developer point of view rather than from a user point of view, which the docs are oriented more towards. Right?
So what would you think of as like, you know, a cheat sheet that you keep referring to, like no matter how far along you are in development with this?
I'm not sure that there is a cheat sheet. Git grep is my best friend. Whenever I can't remember how something was done, git grep, see where we are. I frequently refer back to these KEPs that I linked to. It's important to note when we talk about enhancement proposals, they are not living documents. For the most part, they're a design proposal at a point in time, the design is implemented, and then it's done. And we don't, like as the system evolves, we don't come back and update all of the KEPs. We've got dozens and dozens and dozens of KEPs that have been implemented. I don't, you ask it, and I'm sort of embarrassed to say, I don't know that there is a true architectural diagram that we've kept up to date.
I don't think so. Yeah.
There are hundreds or thousands of talks that people have given that you can find on YouTube and other places that include diagrams that are approximately architectural diagrams. But I don't know that we have one that's checked in as the source of truth.
I think there's the one Brian did 5 years ago. I think that's the only one that's still out there. Yeah. So but fundamentally, the architecture hasn't changed, right? I mean, there's been a lot of change in the project, but fundamentally, the architecture hasn't changed.
Good first issue, update the diagram.
I think there is an issue out there to do that. It's
John, if you let me share screen, I can share screen.
I can. Does it not? It's not letting you in. I have to enable that for you. Okay.
Yeah, host disabled attendee. Now I can see it. Share a Chrome tab. So like, here's my architectural diagram from a slide deck that I did 8 years ago. And it's fundamentally the same diagram, right? You can zoom in on it a little bit more and get some sense of the controllers and the data storage side. But like fundamentally, this is the same diagram. Which of course is not a super interesting diagram. Like the details aren't here. Like I said, it's a fractal, right? You can take any one of these boxes and then zoom in on it and zoom in on it and zoom in on it.
Okay. Any other questions? Yeah, that would probably be, well, that is something you can help with if you're interested in.
Contributions are always welcome, with the caveat that things like diagrams, unless they're kept up to date, become actually worse than not having diagrams, because then they become lies.
Fair enough. Okay. All right. Any other? Yeah, code and view diagram. Yeah, exactly.
I mean, that's a challenging thing to say when Kubernetes spans 100 repos and
exactly.
Tens of millions of lines of code, but
that'd be a great. Now there's an application of AI. Go ingest all that code and spit out a pretty diagram and keep it up to date. That would be pretty cool. Awesome. Anything else? Okay, well, thank you all so much. We'll see you in a couple of weeks, and good luck to everybody who's joining the community. We'd love to have you on board.
Welcome to all the new folks. Find a SIG that scratches an itch that you've got, whether that's learning something or working with something you already know how to do, and jump in. The water's warm.
Bye-bye.
All right. Have a good one.